Welcome you all to the Research Spark YouTube channel. This is Dr. Veer Chandra and we are discussing about the signal processing course, and today we are going to start the unit second, analysis of continuous time signals and systems. Left side having the syllabus and right side contains the outline of this session. So in this session, we are going to discuss the Fourier transform, inverse Fourier transform, and the properties of the Fourier transform. So let us start from the Fourier transform. So first thing is that what do you mean by the Fourier transform? So it's simply this is a tool operation which can be done with any system, any signal. Suppose if you'll have the signal f of t, then if you wanted to change from time domain to frequency domain, then one can use the Fourier transform. So Fourier transform is a nothing simply technique to change from time domain to the frequency domain. The question is that how we'll do that? So simply suppose f of t, if you wanted to change, then multiply it with the exponential of minus of j omega t and integrate it over minus infinity to infinity with respect to dt. This will give you the function in the frequency domain. So e to the power j omega t only representing the complex exponential functions, that is the sine and the cosine components, and f of omega is nothing the finally the converted, that is the Fourier transform of your ft signal. As for example, let's consider the example of cos of omega t. So if you change it this t into the omega domain, that is frequency domain, then do the same things, means multiply your function cos omega t into e to the power minus j omega t and integrate it over minus infinity to infinity. So how can we do it? So you can replace your cosine function with the exponential in order to solve this problem with the help of your Euler's formula, because Euler tells that cosine function can be represented by e to the power j omega t plus e to the power minus j omega t divided by 2. Now change these values in the primary equation and solve. You will get the final Fourier transform of the cosine omega t. Here are some popular results, like the Fourier transform of del t. Del function is simply 1. Ut step function is pi del omega plus 1 by j omega, and also you can check the other results. Now next is your inverse Fourier transform. So simply converting back into the time domain from frequency domain, that is a inverse Fourier transform. So mathematically how can we do? So just multiply with the e to the power j omega t and integrate it over minus infinity to infinity with respect to d of omega divided by twice pi. So this will give you the time domain signal of your frequency, that is a Fourier that you have already done with the Fourier transform technique. So you can pay your attention. If you are taking the Fourier transform of any signal, then multiply by the e to the power minus j omega t, and if you are taking back inverse Fourier transform, then multiply with the positive, that is e to the power positive j omega t. Some popular results you can check here. The inverse Fourier transform of 1 is del of t, pi del omega plus 1 by j pi is your j omega is your u of t, that is unit step, and rectangular functions if you have, then sinc t you will get the inverse Fourier transform. Here is your example. If you wanted to convert back, that is if you want the inverse Fourier transform of the rectangular function, that is the rectangular of omega by twice pi, then you will get the same values, the sinc of t, that is the sine pi t divided by pi of t, that is also being called as the sine of t. So how will you get? Multiply by the e to the power j omega t your function and integrate it over minus infinity to plus infinity. Since your rectangular function lies only in between minus pi to pi, so it will have the values only in this region and integrate it over. Some properties, now properties of the Fourier transform. First, linearity. It will have these properties. Time shifting. This one is the most important. If you are shifting in the time domain, then frequency domain directly you can multiply with the e to the power minus j omega t naught. Means you need to take the Fourier transform after time shifting. So means before time shifting, whatever the Fourier transform you have, so just repeat the same things, just multiply by the e to the power minus j omega t naught. Then the frequency shifting, scaling, time reversal, all these are the important properties. So check all these properties. Convolution is another and important. So in the time domain, if you are taking the convolution in the frequency domain, simply the product of that functions. These are the some more properties. So example, let's consider the example of the time shifting. So as per the properties, since we are shifting in the time domain, that is t minus t naught, so in the frequency domain only it will multiply with the e to the power minus j omega t naught. So let's consider an example of e to the power minus t having the functions ut only, means it will have the only the values in t greater than equal to 0. So how will you take the Fourier transform? Simply just multiply with the e to the power minus j omega t and integrate it over minus infinity to infinity. Since minus infinity to 0, this function will not have any values because of ut. So now integrate it over 0 to infinity, you will get the f of omega is equal to 1 by 1 plus j omega. Now, if you are going to shift by t is equal to 2, t naught is equal to 2, then the shifted function is f of t minus 2 is equal to e to the power minus t minus 2 u of t minus 2. Now take the Fourier transform, you will get the f of omega is f of omega into e to the power minus j omega 2. So that is simply the multiplication with the e to the power minus j omega t naught, that is 2. So it satisfies the time shifting properties. So this is the simple technique to find out any Fourier transform if you are shifting in the time domain. Another example is a scaling property. So how will you do? So if you are scaling in a time domain by any amount a, then what will you get in the frequency domain? Simply 1 by modulus of a and f of omega by a. So you will get the this with the help of this technique you can find out the frequency domain, that is the Fourier transform of any signal if you know the Fourier transform of f of t. So here is an example. Suppose example f of t is your e to the power minus of modulus t. So take the Fourier transform, f of omega will be your twice of 1 plus omega square, and then shift it by 2, that is f of 2t is equal to e to the power minus of twice of 2 modulus. Now if you are using this property, then you will get f of twice of 2t is equal to 1 by modulus of a, that is 2, and f of omega by 2. So it will be equal to the 4 divided by 4 plus omega squared. So solve this, and this is the simple way to do the scaling. So you can do the some more exercise with these properties and the Fourier transform and the inverse Fourier transform, and also we'll see the analysis of the LTI CT system using the Fourier transform and then the frequency response in the next session. Thank you for listening. If you have problem, please drop your comments. Thank you.